So in this video, we're going to look at how to organize data into simple tables. And the most important thing about producing any data table is to make sure that you plan in advance. Instead of just making the lines and starting to throw numbers and headings and labels in, you really want to think about in advance how you want to organize this data table, whether it's a simple table or a complex table. So for the purposes of this video, I'm going to use this data that I collected on T-Rex. So I have some information about different sizes for T-Rexes. I have 5 sample A, B, or specimen A, B, C, D, and E, and I want to organize that into a simple data table. Now normally on a separate sheet of paper or maybe on a piece of scratch paper, I would try to organize to think about what are the labels going to look like, what units do I need to use, how big does the table, how wide should I make the columns. For the purpose of this video though, I'm going to go ahead and do that directly onto the graph paper. But normally I would make the practice or the sketch on a separate sheet of paper. So looking at the data, I have for each of the T-Rex, I have one specimen name, whether it's male or female, the height, the length, the estimated weight, and the last thing is the longest tooth. So that's 6 things that I need to get into this data table, or 6 pieces of information, including the name of the specimen. So I'm going to go ahead and start writing some of the information that I need up here. So first there's going to be a specimen. I know that there's going to be the sex of the animal. There's going to be the height. There's going to be the length. There's going to be the estimated weight. And lastly, there's going to be the longest tooth. So those are my 6 pieces of information. Also, I'm going to have units for some of these numbers. So for example, the first 2, specimen and sex, those have no units, but the height, that does have units. So I'm going to need to somehow get in there that this measurement is in meters. I know that the length is in meters. I know the estimated weight is in metric tons. And the longest tooth is in centimeters. So it's really important to write all of the information that will ultimately end up in your heading labels at the top so you can see how big you need to make this thing. How many boxes do you need to designate for these labels at the top? How wide should they be? Now, one of the things that I really want to stress for making these data tables is that they should be very clear. They should not be repetitive. So in other words, if you look at the original data set, how many times the unit meters shows up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times it shows up. Metric tons shows up 5 times. Centimeters shows up 5 times. But in my data table, I'm going to reduce that down by only putting the units a single time at the top, and we're basically taking advantage of a mathematical property called the distributive property, in that everything that falls under that column will have those same units and will always represent, for example, the length of the animal. So we want to make the table very concise and not be so repetitive with the information connected to the numbers. We want to keep the numbers just by themselves so they're nice and clean, easy to see, and easy to compare with the other lines that we'll see in the data table. So for myself, looking at especially this one over here on the right, this one looks like the one that's going to take the most space. So what I'm probably going to do is make 1, 2, 3, 4 blocks high. So my heading that goes across the top is going to be 4 blocks high. That's going to make sure that I can fit all of these, but then also fit in my longest or my most information that I have, which is the estimated weight. Okay, then the next thing I want to try and figure out is, after I make the heading label at the top, how far down am I going to go? So in this case, there are going to be 5 rows after the heading at the top, one for each of the 5 letters representing the 5 different dinosaurs. The information that's going to go in those is only going to be informations like, for example, the letter A, the number 4.1, the length of the tooth, 30 centimeters. So those boxes probably don't need to be quite so big. I probably could get away with making them only probably 2 boxes high, plenty of room for me to be able to fit all of the data. The last thing then I need to think about is, since I have 6 pieces of information, I need to think about how wide will each column be. One of the things in making a very professional table is you want to try to make sure that your rows are all the same width, or height I should say, and that your columns are all the same width. So for myself, I would count the number of blocks just to try and figure out how much space I have to work with. So starting from here, 2, 4, actually let's start over here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8. So I have 30 blocks to work with going across. So I can make a couple of choices. I have 6, so I can make each of the blocks 4 blocks wide. And 4 blocks is about that wide. That probably will fit. I could make it fit, but I'm going to make the data table a little bit wider, and I know that it's going to fit because I know how many I have. I have 6 columns, and I know that if I make them 5 blocks wide, that will be 30 blocks total, and I'll definitely be able to make it. So what I'm going to do right now is I'm going to go ahead and start laying out the outline of the data table. So I'm going to start over here on the left-hand side. Just going to make a very faint dot on my first square, and then I'm going to count back again to find out where that 30th square was. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8, 30 is right there. Okay, so now I'll go ahead and create that first line. This is going to be the top line of my data table. And one thing that's really important is I want to make sure that I always use a ruler for making the lines. Okay, so when I make my line, I don't guess how far it's going to be. It's not going to be dangling off the end. I'm not going to stop short and then have to add more to the line. I know I've made this thing wide enough in order to be able to fit all of the data. So I said that I was going to make the top heading a little bit bigger so that I could accommodate all the information I need to, and that's going to be 4 lines. 1, 2, 3, 4. So that's this line. So the trick is now I don't need to count anymore. I have the first line put in, and I'm going to make every single one of my lines exactly the same length as this one. And every line is going to stop exactly at the right place. So this is where my heading will go, and now I'm going to start making the rows for each of the entries. So here's where the information for T-Rex A, T-Rex B, T-Rex C, D, and lastly E. So this is the bottom of my table. So when I make my vertical lines, I won't be guessing where those vertical lines are going to end. I know where they're going to end. This is the bottom line for the table, and no line will need to extend beyond this point. Okay, so there's my rows. I said I would make them 2 blocks high. I have dinosaur A, B, C, D, and E. I have my room for my headings. Now all I'm going to do is I'm going to turn this just a little bit so that I can start putting in my vertical lines. I said that I would make the blocks 5 wide, so 1, 2, 3, 4, 5. One, two, three, four, 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 5. And my last one, 1, 2, 3, 4, 5. So that worked out perfect. And I'm going to cap off all these lines. Okay, so when you look at the data table now, I don't have lines dangling off the right side. I don't have lines coming down. I don't need to erase. I don't need to extend any of the lines. All I did was just count a couple of times to make sure how long each of the sides and each of the lengths would be. And then from there, I just continued the lines. I only had to count this one, and then I only had to count 2 blocks going down, very easy to do, and then going across, I just had to count every 5. It just takes a few seconds. And the table looks so much better, so much more professional, cleaner, and neater. And now, again, normally these would be on a separate sheet of paper. Now I'll just transfer all that information. I know where everything's going to be. So the last point that I want to make about the data table is you want to try to center everything, both left to right within each cell and top to bottom within each cell. So when I write the word specimen, for example, I have 4 blocks. I'm going to put it right on the middle of the middle 2 blocks. Same thing with this word. Since this is a pretty small word, I'll start closer to the middle. For height, I'm going to go up a block. So that's going to be height. And that will be in units of meters. I'm going to do the same thing for length. That's also in meters. Now I have estimated. So this one is the longest one. And lastly, the longest 2. So now this is 3 words. So I'm going to start it close to the top. So everything is roughly centered left to right and then also top to bottom. So now all is left to do is to take the data table and start transferring the information. And this won't take but about a minute or so for me to get all the information in there. Again, I'm going to try and put everything in the center, both left to right and top to bottom. So for this one, we had 2 females, then there were 2 males, and lastly 2 females. So I'm just going right down the list. Next is height. So I have 4.1, 3.9. Again, I'm going to try and center this as best that I can. One thing that I'm not going to do though is I'm not going to put the units. So the units are here at the top. It's using a distributive property that they apply to everything in the column below them. So there's no reason to put anything except for the numbers. Then we'll go through the lengths. The weight. And lastly, the longest tooth. And we're done. This is a very well-made table. It's very clear. It's easy for me to compare each of the individual, for example, lengths, to compare how the lengths. I can see things like, for example, that the male T-Rexes generally are a little bit shorter than the females, also a little bit shorter in length, also smaller typically in weight. Things like this start to jump out, whereas the original data, which has all the same information, but it's very repetitive and very difficult to make comparisons, much cleaner now that it's in a nice, concise data table. I've pulled all the units up to the top, and now I can compare the numbers in the data a little bit more easily. So again, the key to making these very professional looking tables is to just take a moment to plan in advance what will the top of this look like, and use the graph paper to count out the number of blocks, both vertically and horizontally, so that you just make that count one time, and when you put the lines down, you know that those lines are exactly the way they need to be.